Welcome to this new presentation regarding differential scanning calorimetry. In this one, we are going to learn how to design good methods to perform good experiments. This is our contents outline. First of all, we will see which are the main parameters that have to be controlled in order to perform a suitable experiment. Then we will see how to define our methods by means of different segments relating temperature and time. And then we will see some methods employed with inert gases and then with reactive gases. Regarding the previous knowledge that you have to know some DSC fundamentals as well as experimentation skills. Let's start then with the parameters. The main parameters are temperature, time and gas of analysis. By the combination of the two first, the temperature and the time, we will apply some different segments, isothermal or dynamic, as we will see. Regarding the definition of the gas for our analysis, we will have to define which is the flux, that means the amount of gas that is passing through by time unit, and also we will have to ask ourselves, do we want our gas to react with our sample? If we answer positive to this question, then we will use some reactive gases such as oxygen, but if we don't, we will apply an inert gas such as argon or nitrogen. How to define a good DSC method? By means of the combination of segments that relate temperature and time. In this way, if we want an isothermal segment, we will fix a temperature during a determined time. But if we want a dynamic segment, we will define an initial and an ending temperature defined by and related by a constant heating rate. Let's start then with the different DSC methods. This method has been named as dynamic scan and it's the most used. First of all, you have to know that the colors that we are using are red for the ones that the DSC is really registering, so it's reading, and blue for the ones that are only for accommodation of our method, as you will see. So with this dynamic scan, we will first heat from the ambient temperature to a temperature above the melting temperature of our polymer, and we will register it. We call this scan thermal history, as you will see. Then we can apply an isothermal very short, just a couple of minutes, in order to accommodate the change of slope, because now we are going to cool down from the melting temperature to the ambient temperature or even below. Then we will apply another isothermal segment in order to accommodate the change between the cooling and the next heating scan, which is really important. Now, if we want to apply an isothermal experiment, we have named it here isothermal scan, we apply some different segments that we are not really interested in. We are just heating up above the melting temperature of our polymer, then we are keeping this temperature through a couple of minutes, then we cool down again, then this isothermal, then we heat again to the crystallization temperature, to this isothermal temperature that we are really interested in, and then the DSC will register this scan. Now, if we want to apply some reactive gases, we have two main different experiments. This one is performed in order to obtain the oxidation induction time. As a first segment, we define in inert gas, we heat from the ambient temperature to a specific temperature, as we will see, and then we keep at this temperature until an exothermal response appears in our DSC registration. That means that we have to apply multiple preliminary experiments in order to achieve this specific temperature and furthermore adjust our method. When this temperature is achieved, we will change the gas from inert to oxidative, in this case with oxygen. Now, if we want to analyze the oxidation temperature, we will apply the following method, in which for the segments 1, 2, 3 and 4 we are erasing the thermal history and preparing our polymer to determine the a specific crystalline configuration in inert gas, and then we will apply the last scan with oxygen. Remember everything we have seen through all this presentation. First of all, we have shown which are the design parameters in order to create a reliable and suitable calorimetric methods. These parameters are temperature, time and analysis gas. Then we will have seen how by the combination of isothermal and dynamic segments you can define your best method. And then you have to choose which gas and what information you want from your sample in order to select the most suitable method. Remember that all the operations that you do in your laboratory must be supervised by qualified personnel from the research group. But now you are capable of designing good methods in order to perform the best experiments for your samples. Thank you.